Subscribers, today is a very auspicious day. uh, Today is Diwali, so I wish all of you a very happy Diwali, and may all of you prosper mathematically. This is the last of the three proposed letter readings for the three letters which I wrote. I thought of writing more letters to him, but I couldn't, and possibly now I will write more letters and which I can rather speak on. So this is again about Pythagoras theorem, because this whole discussion was about Pythagoras theorem. But today we are going to learn something very interesting, a fact which is not so evident, but you will soon see what it is. So, dear Arya Singh, today I will tell you an interesting fact about the Pythagoras theorem. So, consider the diagram on the left, which is here, where I have a right angle triangle ABC whose vertical line has a length x, whose horizontal base has a length y, and whose hypotenuse has a length z. So here an important question is to find integers that satisfy x square plus y square is z square. So find sides with lengths integer, that is x has to be integer, y has to be integer, z has to be integer. Then you have 3, 4, 5 as one of the answers. So, but I'll ask you to find those integers x, y, z whose greatest common divisor is 1. That you take any any among these 3 points, the only common divisor that they have is 1. Right? For example, if you take 3, 4, 5, so you take 4 and 5, what is the common divisor? That is 1. So if you take any 2 points here, their common divisor would be 1, right? So of course, let me give you a reason why I ask you to do so. Suppose I give x equal to 3 and y equal to 4 and z equal to 5. Of course, you can say, of course, x equal to 30, y equal to 40 and z equal to 50 is a solution of equation 1. Of course, you are right. But observe that GCD of 30, 40 and 50 is 10. The greatest common divisor of these three numbers is 10. If we write 30 square plus, if we write 30 square plus 40 square is 50 square, then of course we can divide by 10 square, that is 100 on all the sides, and pull the 10 inside and cancel it with cancel the 30 with 10 and have 3, 4, 5 back again. So it's to find integer solutions, it's enough to be interested in integers whose greatest common divisor, HCF, right? GCD is equal to 1, right? That is the only common divisor of x, y, z is 1. So this you understand. So it's enough to do that. Once we set this up, once we can get this, what we will show that z, the length of the hypotenuse, is always odd. This is a very fascinating feature, that if you have x, y, z, all of them integers, and whose GCD is 1, so then the hypotenuse must be, the length of the hypotenuse must be an odd integer. Isn't that fascinating? It won't come to your mind so easily that it is an odd integer, but it is an odd integer. First of all, note that all numbers x, y, z among the three numbers, which we call the Pythagorean triplet, all of them cannot be odd. If x, y, z are all odd numbers, then so is x square, y square and z square, because if you square odd number, you will get an odd number. For example, if you take 3, square it 9. If you take 5, square it 25. They are all odd numbers. So x square plus y square plus z square will mean then odd number plus odd number is equal to odd number. But sum of two odd numbers is always even, right? But how do we know all this? Let us see that sum of two odd numbers is always even. So this can never happen. So all of them cannot be odd. At least one of them has to be even, right? So but how do we know all this? Note that any even number can be written as 2 into k, that is any even number beginning from 2 and more can be divided by 2. So 2k for any k which is a positive integer. Thus, any odd number other than 1 can be written as 2k plus 1. If I put k equal to 0, I'll get 1. So okay, I'm not bothering about 1. So anything bigger than 1. So when I put k equal to 1, I'll get 3. When I put k equal to 2, I'll get 5 and so on. Of course, if 1 allows k equal to 0, then we have 1 is 2 into 0 plus 1. However, we will bother only about odd numbers more than 1 for the time being. So now let us take an odd number and square it. So what we will get, 2k plus 1 whole square by using the formula of a plus b whole square, which is a square plus 2ab plus b square, will give me 4k square plus 2 into 2k, which is 4k plus 1. So it will ultimately, we can factor the whole thing in this way, 2 into 2 k square plus 2k plus 1. So here is an integer. So 2k square plus 2k is a positive integer, and since k is a positive integer, 2k plus 1 whole square is equal to 2 into a positive integer plus 1. Hence 2k plus 1 whole square is an odd number. So the square of an odd number is an odd number. Here's the mathematical proof of it. You don't have to check with some numbers. It's true for all odd numbers. Now let us have two positive numbers which are odd, and then let us add it. So two positive numbers odd, any positive number can be written as 2k plus 1. So one of them is written as 2k plus 1, another is written as 2n plus 1. So finally if you add them, it is 2 of k plus n plus 2, 2 of k plus n plus 1. So it is again an even number. Any 2 into some positive number is an even number. So the sum of two odd numbers is even. So if you have both x and y say is odd, then their square, if you make up, they cannot be odd. Right, then it will become even. So all the Pythagorean triplet cannot be odd. That is a very important thing. So at least one of them is even. In fact, among x, y, z, no two of them can be even. Otherwise, those two will have a common factor 2. But we have stated the fact that all of these x, y, z have a common factor 1. Right? So among x, y, z, there is exactly one number which is even. I am sure you have now got a hang of it. So there is exactly one number which is even. Now we will show that z, the hypotenuse, is actually odd. It's always odd. Suppose, now what we will now show that z is always odd. Suppose that it is not true, and suppose that z is even. Then x and y must be odd numbers, right? Because there is exactly one even among those three. So the two are odd. So x is written as 2k plus 1, where y is written as 2n plus 1, and z is written as 2p, an even number, where k and n and p are some positive integers. So let us square x, which is 2k plus 1 whole square, which is 4k square plus 4k plus 1. Let us square y, which will give you 4n square plus 4n plus 1, which is 2n plus 1 whole square. So x square plus y square is, when I add them up, is 4k square plus n square plus 4n plus k plus 2. So here is an even number. Now z square is 4p square, which is 2 into 2p square. So x square plus y square is equal to z square. So these are Pythagorean triplets. So I'll have here 4k square plus n square plus 4k in 4 into k plus n plus 2 is 2 into 2p square. So after I do this, after I make these cancellations of 2 on both sides in the second line, what I ultimately have here is 2 of k square plus n square plus 2 of k plus n. So here I have an even number plus 1. So this is an odd number, is equal to 2p square, which is an even number. So here on the left side I have an even odd number which is equal to an even number, which cannot happen. An odd number doesn't equal an even number. But here we reach a contradiction. The number on the left hand side is 2k square plus n square plus k plus n plus 1 is an odd number, while the right hand side we have 2p square, which is an even number. So we have odd is equal to even. What a bad thing, of course. So our initial guess that z cannot be even is wrong. Initial guess is wrong. So z cannot be even. So it is always odd. So among x, y, one of them must be then odd. That is all for today. More follows next week. Or that next week never came due to this COVID, and I got into a lot of other issues. So now I start writing to him again. He has grown up in these 2 years, so more slightly more advanced things can be told to him. Bye for now. Love, J2. I hope you enjoyed this. In this, I thought just to come to the office just before I would also like to start my Diwali celebrations, and so that you learn some lovely fact on Diwali, that always every day if you progress a little bit, just learn at least one new thing, you will be a more happier person. So the learning is, if x, y, z are Pythagorean triplet where z is the hypotenuse and x and y are the sides, then if GCD of x, y, z is 1, then z must be an odd integer. This is amazing. Isn't mathematics beautiful? Thank you. Have a nice celebration.